Homework sheet U11d question 7. We're asked to express 5 over x minus 1, 3x plus 2 in partial fractions. So these are going to take the form a over x minus 1 plus b over 3x plus 2. If I multiply up by my denominators, then I get 5 is equal to a lots of 3x plus 2 plus b lots of x minus 1. If I substitute in x equals 1, then I get 5 equals 5a, so a is 1. And if I substitute in x equals minus 2/3, then I get 5 is equal to minus 5/3 b. Therefore b is equal to negative 3. So my final answer is the 5 over x minus 1, 3x plus 2 can be expressed as 1 over x minus 1 minus 3 over 3x plus 2. In part B, we have to integrate our algebraic fraction from before. We can replace it with the partial fractions that we've just found. In each of these cases, the numerator is the differential of the denominator, so we don't need to do any multiplying of the top, and we can just integrate to get the natural log of the denominator in each case. Log x minus 1 minus log 3x plus 2 plus a constant of integration. Part C now gives us a differential equation to solve. We start by rearranging our differential equation, separating the variables to get all our y terms on the left and our x terms on the right. This gives me the integral of 1 over y dy equals the integral of 5 over x minus 1, 3x plus 2. This right hand side is the answer that we've just got in part B, so log x minus 1 minus log 3x plus 2 plus c. Our left hand side just gives us natural log y. Now I'm going to want to simplify this expression the best I can. If I can combine my two logs on the right hand side into a single logarithm, I can get log x minus 1 over 3x plus 2 plus c. I can raise both sides to be the power of e, and that will get rid of my logs on both sides. Y equals e to the log x minus 1, 3x. Do that again below. Y equals e to the log x minus 1, 3x plus 2 plus c, which I can separate with indices rules to get times e to the power of c. And e to the power of c is just a constant, so I'm going to replace that with a new constant a, and e to the natural log of something will just give me what I've got left, so I get x minus 1 over 3x plus 2. No more logs. I can now use a bit of information that I was given at the start of the question, which is that at y equals 8, x is equal to 2. 8 therefore is equal to a lots of 1 over 8, which means that a is equal to 64. And so for my final answer, y is equal to 64 lots of x minus 1, 3x plus 2.